Welcome back. I am Mr. Eicher, and this is the third part of a lesson about the law of sines. We're going to be needing a calculator, so take your calculators out. We're going to be finding missing angles with the law of sines. So let's get started. Solve the triangle with the law of sines. Round the sides to the nearest thousandth and angles to the nearest tenth. So first thing, we'll sketch a diagram. So don't know what exactly triangle ABC looks like, but we'll go A, B, and C. Kind of like to do the A and B to the left and to the right of each other at the bottom there. So angle A is 25 degrees. The side opposite of A is 13. And the side opposite of B is 12. So here's our setup. That's our triangle. And we'd like to solve the triangle, which means to find all the missing sides and angles. Now, for this triangle, we're not able to do the 180 minus the other two angles because we only know one angle, so that's not going to work. So instead, we're just going to jump right into the law of sines. Oh, by the way, we can't use the Pythagorean theorem because we don't have a right angle, or at least we don't know if it's a right triangle. It might look like, is angle C a right triangle? Well, it may or may not be. So we're going to start with the angle that we know and the side that we know from that angle. So first thing, number one, we're going to do sine of 25 degrees over 13. And that's going to equal, well, we can't use angle C. We don't know angle C, and we don't know the side opposite of C, but we do know this side is 12, and the angle opposite of that is angle B. So we could write sine, now this is a little different than the previous lesson, sine of the angle, we don't know the angle this time, but we do know the side opposite of that angle is 12. So this is what we need to solve. So to solve this, we're going to multiply these two together, and we're going to multiply these two together and make it an equation. So we're going to have 12 sine 25 degrees equals 13 sine of angle B. We would then divide both sides by 13. Get rid of this one. There we go. So sine B equals that. Now there's a couple approaches you could do. Students who like to type it all at once in your calculator, that is possible. You could do it that way. But I'm going to just type 12 sine of 25, hit enter, divide by 13. So my calculator has this number in it. 0.3901091647 equals sine B. Do you remember how to solve for an angle whenever there's a sign next to the angle? Do you remember the inverse operation to use? Well, that inverse operation, angle B, would equal arc sine, also known as inverse sine, also known as sine with a little -1, of that whole number. I'm just going to put dot, 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 because I don't want to have to write it all again. I have that whole number in my calculator, so I'm just going to do second sine and then that long decimal. And I get an angle equal to 22.96, which is going to round to 23.0 to the nearest tenth. So that is my angle B, which I will write in the triangle, 23.0. Now for solving angle C, the measure of angle C, we could do the 180 minus the two previous angles. So 180 minus 25 minus 23.0. So the measure of angle C is 32 degrees. It's definitely not a right angle. It's much bigger than a right angle. So we have this angle is 132 degrees. Lastly, we have one more side. We need to find this side down here, which is lowercase c, since it's opposite of the angle, capital C. And we know that the angle that we just found is 132. So we set up one more time a law of sines ratio. We have sine of 25 over 13, that was my highlighted green one, equals sine of 132 over the side C that we're looking for. When we cross multiply and solve, we would get 13 sine 132, and doing an extra step in there, we'd be dividing by sine 25. So 13 sine 132 divided by sine 20. and I get the side is 22.8595. That rounds to 60. So this side is 22.860. So we have, just to check our answers, the biggest angle is opposite the biggest side. That looks good. The smallest angle is opposite the smallest side. That looks good. And the middle angle is opposite the middle length side. So that looks good. Looks like we have everything set. For a try this, I'd like you to try question number 5, where you have to find a missing angle. And you are solving the triangle, so you have to find several different components. And then lastly, I'd like you to solve number 6. I will get you started on number 6 to make sure you have the diagram right. Number 6 says, Sarah Phillips, an officer for the Department of Fisheries and Wildlife, checks boaters on a lake to make sure they do not disturb 2 osprey nesting sites. She leaves a dock and heads due north, so she starts here. She's heading due north, so up on the page is north. In her boat, from here, the first site, she turns 5 degrees this way, north of west, due west, and travels an additional 2.4 miles to the second nesting site, which is right up here. Then she travels 6.7 miles directly back to the dock. So then she travels this 6.7 miles directly back to the dock. How far from the dock is the first osprey nesting site? So we're looking for this length x. So just notice that this 5 degrees that I wrote in there, this entire angle would be 90 plus 5 degrees. So that entire angle is 95 degrees. So if it helps you, you can redraw the triangle. It looks kind of like this. You're looking for x. This length is 6.7 miles. This length is 2.4 miles. And this angle is 95 degrees. So I hope that is enough of a diagram to help you figure out what is the measure of angle x. Notice that you have a angle side pair. But notice you're going to have to find this angle first as a first step to be able to then find this angle as a second step, and then finally as your third step you would be finding the length of x, the distance from the dock to the first nesting site. Thanks for watching this video. I'll see you next time. Bye.